Hello all who decided to look at my project today. I'll be discussing the king of elements known as carbon. Now, let me first explain the basics of carbon. Carbon has the atomic mass of 12. It has a solid state. It's classified as a non-metal. Its melting point is 3,500 degrees Celsius and its boiling point is 4,827 degrees Celsius. It has 4 valence electrons, which means it has 4 electrons on its outer ring. It has a combining capacity of 4, which means it's missing those 4 electrons that it needs to complete its 8 set. It has 6 protons, 6 neutrons, and 6 electrons. When it comes to its ionic charge, it's really special. It doesn't really take or give away, it sort of just shares with one another. For example, we have carbon dioxide. You see the oxygen just on this side and oxygen on that side, and you have carbon in the middle. As you can see, it's electrons right here. You see, they're not really taking from each other, but they're sharing it. What's happening here is that they're both spinning really fast to the point where they have all their 8 electrons that they need. Moving on to macromolecules. A macromolecule is a formation of different atoms to make up bigger molecules. Carbon is located in all 3 main macromolecules: your amino acids, your lipids, and your saccharides. There's so many, I will only focus on the saccharides. Now these are your sugars and your starches. These give ATP energy to your mitochondria so we can do things on a day-to-day basis. The main type of sugar that humans consume is glucose. Glucose are also known as a simple sugar or a monosaccharide. It comes from the carbohydrates that we eat from a day-to-day basis. 100% of the carbs we eat turns into glucose. Associated functional groups are hydroxyl and carbonyl groups. Now, in this projection of a monosaccharide, it's very important that this carbonyl group up here stays where it is. It makes the difference between a fructose and a glucose. Now, this is the difference between eating something like a bag of chocolate chips or something like eating a watermelon. How is carbon used in the real world? Carbon can be implemented into creating light yet strong and durable fibers. These carbon-made fibers are mostly associated with things where lightweight and strength are extremely useful. These can include a wider range of sporting goods, airplanes, aerospace, and even strengthen other materials and wood. Some quick facts about fibers: 80% less dense than steel, thinner than a human hair, high strength-to-weight ratio, and 10 times stronger than steel. Now, how to make this stuff? It's really complex. Carbon atoms are used to bond the organic material together to form the carbon fiber. Now, there's 3 steps to this process. There's carbonization, oxidation, and sizing. The more important one is carbonization. This is where you're going to get your carbon-based material. As you can see, this is the uncarbonized carbon material, and the other atoms, you can say, or elements that are attached to it, it's going to go through the furnace and then pops out this extremely carbon-based material. As you can see, the other atoms aren't really gone, they're just pushed out. Now, also with this extreme heat and pressure, greater bonds between the carbon atoms are made. Now, the other processes, oxidation and sizing, are really useful too. Oxidation makes better bonds between the carbon atoms, and sizing makes the carbon material itself. Lastly is the way that carbon cycles through the earth. Now, I said earlier that carbon is in a solid state, but it's well known in its gas state. As you can see here, atmosphere is giving this plant carbon, and this plant is turning that carbon into oxygen, which animals breathe. However, if an animal were to eat this plant, that animal would receive the carbon, and if the animal were to die, the carbon would release back into the air. This can be sped up with the process of decomposers, like fungi or vultures. Humans have a process in this too, and they've really kick-started a large amount of carbon that's getting to the atmosphere that's actually hurting it. Basically, through the exhaust pollution of carbon monoxide, they are releasing so much carbon into the ozone layer that it's really tearing it apart. And with this, the solar radiation leaks in through the ozone layer, and it's starting this thing called global warming. Carbon is a really scary thing, yet we use it a lot. We need this. We are carbon-based life forms, and if it wasn't for this, then we wouldn't be humans. Thank you for listening to my presentation. Hope you have a good day.